Good afternoon and welcome back again. Today we have, I think we stopped here, right? The summation. You don't need to. Let me do it. We stopped here. We talk about, if you remember, we see that we have this formula. And I think I left that one as a homework for you. So kindly do it and think about it. Here's this formula is generally talking about Fn and n factorial. We are going to the summation. Summation is what generally we have something we added, and you saw this one in Cal 2 in many cases harder. But now here we have what? We have also we have a, what do you say? We have a series, but we are not talking about convergence or divergence, just talking about general series. Look at here, generally you can write like that, or like that. For example, you can see we have going to infinity, or maybe it's going to 10, 100, we don't know. Maybe it's finite, maybe it's infinite. If we have number here, we see it's finite, any series. If we have I from 1 or 0, whatever, I from 1 to infinite, this is called finite series, and this is called infinite series, right? And it's easy, so that one. For example, each iteration we are given to increase number of j, I, whatever we have. We have j start from 1, so I say 1, 2, right? So I say is 1 plus 2 plus 3 plus, and go till 100. And of course, you know about, if I have 5, we say 1 square. Now, my rule is what? J square. J is increased 1 by 1. So 1 plus 1 plus 1 plus 1. And each step are square. You got it here? So, and also maybe it's iterated between 1 and minus 1. Look at here. We have k start from 4 to 8. In that case, I'm going to substitute k as a 4, 5, 6, and 7, and 8. Understood, dears? So I say this one, that one is cancelled, that one cancelled, it remains only 1. Clear? Do you have any question about how to expand the series? I think it's easy for you. And of course, if we have a square, we are going to add them. Maybe we start, maybe look, we change something. J here start from 1, but here k start from 0. And instead of that one, we change it to what? We change the index and the final number. What do you mean by that one? This example told you that you can play with the indexes or index, and of course we should also play with the here, because we see both they are equal. What do you mean by that? If I expand the first to the left, I know I will get 1, 2, 3, 4, and 5, all of them square, am I right? How about here? I'll get what from the right side? Again, I will get 1, because if k is 0, I get 1. 2, 3, and 4. When k is what? K is 4, I'll get what? 5 square. Because k is 0, k is 1, 2, 3, 4. You got it here? You can see from right and left side they are equal. But what's different between these two series? We just change the indices or index of each one of them. Clear? Good. We saw this series, and of course the proof is not a requirement for you, but we saw such series like that. It's called geometric series. Do you remember? We say it's converge when r between 1 and minus 1 and blah blah blah. We see many things about it in chapter in calculus 2, but here no. Here we are just taking the result. If r is equal to 1, means that if you have here we say equal to 1 to power, for example, n or j. In that case, we are going to use this formula. Otherwise, if greater or less than 1, we are going to use that formula. Okay, for example, if I have 1 over 2 to power n, I see the summation is equal to AR n plus 1 minus AR minus 1. If you remember, we use a simple formula in Cal 2, sorry. Use that one, but where? For which R? If R is converged, right? Am I right? When R is between these two numbers. So generally speaking, you can use this general formula for all cases that we have. R equal to 1, R less than to 1, R is greater than to 1. So we have these two formula. Okay, dears? Any question? May I give you example? No. Because if I say 2 to power n, you say this is what is diverge, or you can say the formula, the sum, because we have a finite. That's why we can add them, and we can we can add them. So that's why now we have n, maybe n stands to 100. In that case, we see it's a converge, right? Because each series, in each series, when we have a summation, we have a finite, we can see converge. For example, if I say I from 1 to million, you can add in, we will get number, right? So that's why in that case, say R not equal to 1, R equal to 1. That's why we are not going to use the previous one. I mean the previous by that one. Understood, dear? Good. So look at this example. Also, we have a double summation. We have ij, and I is fixed. For example, I say I is start from 1, but j will play like a 2 loops together. You have in the programming, right? R is going to there, j is going to there, then which loop is the last one? That one will play. Then the first one will be fixed. The same thing is true for here. You can see we have I from 2, 4, j to 3. So I say I is fixed. I is fixed. So 1, 2, 3. Now j is finished. The loop of the j finished. Do you have a problem? So we say I is fixed. Now I'm going to open j. J is 1, 2, 3. Then we multiply here. I'll get what? I, 2i, 3i. Understood? Then we are going to play with what? Manipulate with the I. So I started from 1, 2, 3. Understood? But if all they are the same, you can say 6i to be more summarized, more summation. Otherwise, you can play with them one by one, and you'll get the same result here or there. Understood? Clear, dears? Good. How about if we have a set? Maybe we don't have a we don't have a natural number set. We have 1, 2, 3, not like that. We have a 0, 2, 4. We just use add or or evens numbers. So depending on the set, or maybe the set is something I'm going to describe. Depending on the set, we are going to substitute. So you see, for example, if we have S, but S is what? S start from here. So I say equal to what? 0, 2, 4. Depending on the situation, depending on the set that we are going to define. About the example 22, do you have a concern? Understand? For example, if I say A equal to 1, 3, 5, so summation I belong to A, I equal to what? Of course, you say is equal to 9. Am I right? Because we are going to add each one by one. Understood? Good. Now, look at this example. The example give you what? You say what? Find the summation, but start from what? Right? 52 up. So you can say that my k from 0 to 100, okay, to k square is equal to what? K from 0 to 15, right? Or 49, sorry, plus 15 to 100. Am I right? Did you understand what I do? Yes. Sorry. We make it separate. We make it two series. The first one from 0 to 100, and the second one is what? From 15 to 100. Do you have any problem with it? Hello? No. Maybe the given say what? Maybe that one is given, and that one is given. He asks you about that. So how you find them? We're going to say 15 is equal to what? Let me say, I change it to here's k from 0 to 49, k from 50 to up. Make it like a x, y, z. So I want to find, for example, z. I say z is equal to what? X minus y. Am I right? The same thing is true for here. The same thing is true for here. We have what? We have z equal to x minus y. Clear? So here's x, here's y, and you'll find the result. Do you have any problem with such number is between? Good. These formula are important actually. You need them during the exam or quiz or assignment. I don't know, depends on the question. This is the geometric, generally, to n. We see that in the previous one. We have two parts. Do you remember? You see if r equal to 1, if r is not equal to 1. So here's r not equal to 1 because this is the general case. We will have what? We have something like that. So if I have 2, let me see, 2k, k start from 0 to 100. If I say find the summation, you should say k is 0, I'll get 1. So a is 1. Am I right? Dears? I'll get what? 1 plus 2 plus 2, 2, and go on. 2 square, I mean 2, 2. So I see the result, it will be r n plus 1. So we have 100. So 101. R is equal to what? Yalla. Kaka Harun, R equal to what? Sakhan, R equal to what? Kaka Lent. R equal to? R is the arithmetic between the terms. We have 2. If I 1 multiply by 2, I'll get 2. 2 by 2, 2 square, and go on. So r equal to 2, a equal to 1. So I say is equal to what? 1 to power 101 minus 1, 2 minus 1. This is the summation or the result of these all steps. We are not going to add one by one, right? Understood what I say? I'm not going to add 100 to 2 power 1 to 2 power 2 together. No, just we have a such thing like that. You got it, dears? Good. How about the second formula? How about the second formula? This is found by Gauss. I think I gave you some things. When he was a first grade in the primary school, he found that one. You see the summation from 1, for example, to 100. If you want to add I from 1 to 100, sorry, not infinity, 100, we say what? I'm not going to say 1 plus 2. Let me change it to 10. I'm not going to say 1 plus 2 plus 3 till 10. No, I say is equal to 10, 11 by 2. So is equal to what? 55 directly. You don't need to add 1 by 1. Understood here? How about the square? If I is square, the formula will be the third one. It will be what? n plus 1. Look at here. If it's a square, it will be n plus 1, 2n plus 1 over 4. Which means that if I want to add from 1 to 10 square, I'm not going to add 1 square plus 2 square by calculator. No, I'm going to, sorry, over 6. Yeah, you're right. The other formula is 4 cube. IC is equal to what? For example, 10, 11, 21, am I right? 210, 20, 21 over 6. Then we will get the result. How about for cube? The same. What do you mean by x between like that? Kaka? What do you mean by absolute less than 1?
Only the negative.
From minus 1. No. Means that the fractions, the rational numbers between 1 and minus 1. Kartakani, Niwan? Kartakan, what do you mean by Kartakan? By 1 over 2, for example, minus 1 over 2, 1 over 100, right? Minus 1 over million, the same. Because they are ratio. This ratio can be put here, and you have this formula. How about if I make that one, derivative of here? Derivative of here by k is equal to what, Jamaat? Day? Exactly. Derivative of here is that one. So make a derivative of here, you will get that one. Because we have x is a function. But do not do like that to here, because it's n, not x. Understood what I say? Clear? Kaka? These, I don't know how many formula we have. 1, 2, 3, 4, 5, 6. These 6, they are important. And you need to use them during the exam. I'm not going to give you. You should do it by yourself. Okay, Kaka? So try to use a lot to deal with it. Now, the previous example, you remember. We say we start from 15 to 100, so add them. I cannot add them. We see we are going to make it y is it equal to x minus y. Do you remember that? How about x? X, it was what? Look. X, it was 1 to 100 squared. So I say, because I have a k square, I am going to use... Again, over 6, you are right. 2n plus 1 over 6. So I'm going to use that one. So n is equal to what? 100. So 100, 101, 201. Tamam? Over طبعا 6. Minus what? N now is 49. So I say 49, 50, 249 is equal to 249.
$98.
98 plus 1, right? And I'll get what? 99 over 6. So I'm going to divide this number and I'll get the result. Clear? Good. So here we are, you can see minus, and here's the result. Any question? Clear, dears? Okay, now if we have an infinite series, of course, in calculus 2, you got many idea about it. Just review it. We don't need all of them. Just these formula that we have. So we have xn. Xn is what? Xn is like a n from like a 1. Look, you'll get 0, x square, and go on like that. So this is the formula, and you should know about it. Okay, dears? Understood? Good. We talked about that one, and we say kaka. We make a, what do you say, derivative, I will get what? I'll get that one. You remember. This is about 2.4, about the sequence. Now this is the second video on it.